my name is Amy Wu. I'm the Year 1 student from School of Hotel and Tourism Management. My question is Mod 3, question number 4A.
Hello, I'm Christy Peng from Year 1 student from SHTM, and I will be doing Mod 3 question 4B.
Hello, I'm Hoshi. I'm from Biology and Biotechnic Year 2 student. I'm going to talk about the Mod 3 question 4C.
Hello, I'm Jason Tsai, and I'm year 1 from SHTM, and I'm going to present about Mod 4 question 4A.
Hello, I'm Venus from SHTM. I'm a Year 1 student, and I will be presenting Mod 2 question 1D.
Let's begin with the first question. Mock examination paper 3 question number 4A. A sales manager would like to compare the recent performance of 2 salespersons under his supervision. From the sales record, their daily sales were normally distributed with the same mean and the standard deviation were $200 and $250. Amount of sales of 10 days in the sales records will be selected randomly for each salesperson. Calculate the probability that their mean daily sales will have a difference of at least $150. So from this question, we can let the mean of x1 minus the mean of x2 be the differences of the mean daily sales between the two salespersons. As we are calculating the differences of mean, we can apply the formula of sampling distribution of differences of mean. From the question, we know that their daily sales were with the same mean and the standard deviation were $200 and $250 respectively. So after the subtraction of mu1 and mu2, we have 0 for the mean. And for the standard deviation, we have the square of 200 plus the square of 250 divided by 10. As we don't know which mean daily sales was bigger, the mean of x1 or the mean of x2, we will have 2 possible outcomes while setting up the formula. So the formula would be the mean of x1 minus the mean of x2 less than negative 150, or the mean of x1 minus the mean of x2 bigger than 150. For the 2 possibility, it is set bigger than 150 over the square root of the square of 200 plus the square of 250 divided by 10. So after calculation, we will have 1.4816. By checking the table of the standardized normal distribution, we can tell that 1.48 is 0.0694. By timing 2 to 0.0694, we can have 0.1388, which is the answer for this question.
Hello everyone, I'm Christy Peng, and today I will be doing Mod 3 4B questions. And the question is, in evaluating the customer satisfaction level, a company would like to be 95% confident that the error in estimating the population mean does not exceed 0.05. If the population standard deviation is 0.8, what is the sample size required? So how can we solve these questions? From the question, we can know that they want us to find the sample size. So first, we have to let n be the sample size required. From the question, we can find that the standard deviation is equal to 0.8. We can also find out the alpha by using 100% minus 95%. So it will be 5%, and it will be 0.05. So finally, we can set up an inequality to find out the answer. So the inequality will be Z alpha over 2 times standard deviation over the square root of sample size. So by substituting the data provided by the questions, we will find that the inequality will become Z 0.5 over 2 times 0.8 over the square root of n will less than 0.05. And under calculation, it will become is at 0.025 times 0.8 over the square root of m will less than 0.05. And after that, we can find out is that 0.025 will equal to 1.96 from the standard normal probabilities table. And keep on the calculation, it will be 1.96 times 0.8 over the square root of n will be less than 0.05. And finally, we can find out that n will be greater than 983.4496. Therefore, the sample size required is 983.4496.
Hello everyone. I'll talk about MOOC 3, question 4c. In a random sample of 500 employees from a large multinational company, 300 said they would like the company adopt a flexible scheduling policy, which would permit employees decide when and how much they would work. Construct a 90% confidence interval to estimate the population proportion of employees favoring the flexible scheduling policy. Explain briefly how the confidence interval should be interpreted. I highlight some important parameters in this question. First, the sample size n equals to 500. Then, the sample proportion p equals to 300 over 500. The degree of confidence 1 minus alpha is equals to 90%. As this question is about the population proportion, we should use this formula: p plus minus z alpha over 2 times square root pq over n. Let's display the known condition of this question. N, sample size, equals to 500. P equals to 300 over 500, which is equals to 0.6. Q equals to 1 minus p equals to 0.4. Alpha over 2 equals to 1 minus 90% over 2, which is equals to 0.05. Refer to the table of standard normal distribution. We can find z alpha over 2 equals to 1.64. Now we calculate the answer. We replace the sample with the number we just obtained. It will become 0.6 plus or minus 1.64 times square root 0.6 times 0.4 over 500, which is also equals to 0.6 plus or minus 0.036. After writing in an interval form, it will become 0.564 to 0.636. Be sure that you write your answer in this interval form.
I'm Tai Kai-in Jason, and I'm going to talk about mock examination paper 4, question 4a. In a study of turnover rate of new employees, after a 1-year period, 150 new employees from the various departments are selected randomly, and 29 of them are no longer employed after the 1-year period. Construct a 98% confidence interval for the turnover rate. First, let P be the proportion of the turnover rate. From the question, we can know that the number of new employees in the sample is 150. So the proportion of the employees are no longer employed after the 1-year period is 29 over 150. As 98% equals to 1 minus alpha, alpha will equal to 0.02. From the table of the student's t-distribution, set 0.02 over 2 equals to set 0.01, and it equals to 2.326. So, a 98% confidence interval for the turnover weights will be 29 over 150 plus or minus 2.326 multiplied square root of 29 over 150 multiplied 121 over 150 and over 150, and it will equals to 0.193 plus or minus 0.075. So, the turnover rates will be more than 0.1183 and less than 0.2683. So the answer will be 0.1183 and 0.2683.
Now let's move on to mock examination paper 2, question 1D. A financial analyst is interested in the percentage of revenue spent by computer software companies on research and development. A random sample of computer software companies is selected, and the results are summarized in the following table. Question 1D. Construct a 99% confidence interval for the mean percentage of revenue spent by all computer software companies on research and development. State your assumptions and/or approximations. First, we find the sample mean. The sample mean from the answer of question 1A is 8.362%. Then we find the sample standard deviation. The sample standard deviation from the answer of question 1A is 1.7370%. After that, we find the total number of computer software companies in the sample, which is the sum of the number of computer software companies, which is 4 plus 12 plus 14 plus 7 plus 7 plus 4 plus 2 equal to 50. The sample standard deviation, as mentioned before, is 1.7370%. As 50, the total number of computer software companies in the sample, is a large sample size, larger than 30. The distribution is approximately normal, so we can use the sample standard deviation to estimate the population standard deviation. So the population standard deviation will be equal to 1.7370%. As 99% equal to 1 minus alpha, alpha will be equal to 0.01. From the table, EZ 0.01 minus 2 equal to EZ 0.005, which is approximately equal to 2.58. 99% confidence interval for the mean percentage of revenue spent by all computer software companies on research and development is 8.362 plus or minus 2.58 multiply 1.7370. Divide the square root of 50. The required mean percentage will be more than 7.7282% and less than 8.9958%. With that, we have come to the end of our presentation. Thank you for listening.